Alright friends, thanks again for tuning in. Here is the 5C collet or tool holder spindle. I've spent the better part of a week working on this and some other pieces. The rest of this video will be focused on making the spindle. I wanted to show the finished product. Here I've got a 7/8 inch 5C collet in place there, and other things I've made this week. Of course, I made the cotters. These are the brass stock, which will become the split cotters for the casting over there. I also made the backplate out of 1/8 inch steel, 1/8 inch thick, and it's 3 inches inside or outside diameter, 1 3/4 inch inside diameter. That'll fit on the back of the casting. I didn't make this, but I modified it. This is a little half moon key that you'll see a little bit later on. I have not fixed that in place yet. In the video, you'll see me talk about, as I get close to the end of the video, when I made last night I made the little screwed, the key, if you can see that little 1/8 inch thick key that keeps the collets from rotating. And during the video, I actually made 2 of these things out of brass first, but they were not a good fit, so I went ahead and remade it, made it out of steel, and then I used my Dremel to smooth down so that the screw doesn't stick up higher than the outside, and then I buffed it out a little bit, so that's why it looks like it does. But that's steel, and it's Loctited in place. I used red Loctite, which is strong but not crazy strong, so I'll be able to undo that with a little heat and force if I ever need to, but hopefully I won't need to. It's made out of steel, it'll stay in place. And then also last night I Loctited on this 2-inch ring on the end, and I used green Loctite on this thing, and it is going nowhere. If you've ever used that green Loctite before, you know you have to heat stuff up super hot and use a good amount of force to undo it. So it's pretty much a solid piece right now. Really happy with the way the spindle came out. It's a good fit on 5C collets, and I'm really looking forward to finishing the project. But stay tuned. The next 20-25 minutes will be about the video for the making of the spindle and some of the other accessories here for the Quorn 5C tool holder. Thanks for watching. Howdy folks, working on the Quorn tool holders. Thought I'd start with a picture of the finished tool holder for the standard, well, basically the standard size tool holder for the Quorn. And I've done a complete set of videos about this, and as you can see, I've got the engraved backing plate on there, and it's all set up, and that's what it looks like. This is the one with the 25 ER collet, basically collet spindle, if you want to describe it as that. So I did a lot of videos about this one and went through kind of excruciating detail. So I'm about ready to machine the 5C collet chuck, or tool holders rather, and I wanted to just show this finished product basically and let you know that I'm going to go through do a video about building the 5C version, but I won't be going in quite the excruciating detail because a lot of the things are the same, and I am very glad that I went ahead and built this first because it was a good learning experience, and I think I'm ready now to begin to tackle the 5C. And so here we have the 5C casting. I've shown this before. I got this from Gary Martin at Martin Model and Pattern, and it is a beautiful piece of cast iron, very similar to the beautiful castings that were in the pillar tool. Somebody on the Quorn group commented about the instructions that come with the large tool holder, and what Gary, I wanted to show that real quick. I'm not going to show every detail, but Gary provides instructions and drawings. These are created by Tom Hammond, who I think is the gentleman who actually originally designed the large tool holder. So he sends you the ones, and now these are the sketches for the R8. And so in order to do the 5C, I downloaded the 5C drawings from the Quorn group, groups.io. There's a Quorn group, and the plans are on there in the file section, I believe. So to answer that question, you don't get the 5C from Gary, but you can download them easily. So I'll get started. I think the first thing I'm going to do is make, and this is a little bit of a difference, I'm not going to split this casting like I did the standard tool holder. I'm going to make a cotter, a split cotter, that's going to go in here out of 5/8 inch brass, and then one for the bottom. So tonight I'm just going to make up my cotter blanks. Here's the cotter blank material. I'm not going to show the whole process, but basically I'm starting with 5/8 inch brass. I'll just cut off this little nub here, drill it, tap it 5/16 24. One piece is going to be about 1.25 inches long, the other one is going to be about 2 1/8. Here's the one thing I did differently for the 5C tool holder. I've drilled and reamed, I'm just finishing the last hole now, reaming it. All these, the holes, the 12 holes are basically the degree holes. I decided to drill and ream all of them in the mill, so that what I've done here, I made a 1/2 inch hole for an arbor, and I'll be extremely careful with that. So I'll put that on the arbor and then turn it around, and then I'll be able to put it back in a 3-jaw chuck and open the opening up to the 1 3/4 interior diameter. But I really like using the pitch circle diameter function on my DRO, and I thought this would be a good time to try that out. Rather than, I have the rotary table, I can do it on there, but I thought this would be a good place for it. The other one didn't have the 12 holes on this thin piece of steel. The conventional tool holder has those holes in basically what they call the index plate, what I call the hand wheel. So that's a little bit easier to grab onto that when it's, inside in the rotary table. A thin piece of 1/8 inch steel, I thought it'd be best to do it this way. Something I did a little differently on this one, since I made the holes already, I was very careful. I made a special, very accurate arbor to put this on. I'll show you that in just a second, so I could get the perfect 3-inch outside diameter. So here's the index plate for the 5C tool holder, and I had an arbor that I had made for something else before, but if you noticed, I bored the inside to a 1/2 inch here when I made the plate initially, and so what I did was I set my arbor in the lathe and I turned the inside down to a 1/2 inch so it would fit that hole perfectly, and then I fit it on there. I just kept turning it just so it was exact with no slop, no wiggle, so it was a nice tight fit, so I was assured of concentricity probably within a few thou for the plate here. So I turned the outside diameter to 3 inches, and you can see it came up nice, worked out really nice, just perfectly actually for the offset for those flathead countersunk holes. So the next thing I need to do is turn it, or place it carefully, and then bore out the inside diameter to 1 3/4. And here I am using some magnets to set this up in the 3-jaw, so I'll have room in the back for the large bore. This is just the initial setup. Magnets are really handy, and I'll be checking it, tapping it, and all with my indicators in a second. Back to the index plate and the careful setup. A minute ago, I'll probably insert a still photo. I used a different indicator to make sure that the plate was flat along this axis. Now I've got an indicator inside there. This is a little interrapid tense indicator to make sure that I'm concentric, and as you can see, it's just a little bobble of the arrow there. I'm really happy about that. Definitely within half a thou concentric with the center circle. That will pay off dividends in the final tool holder. And here we are with the center bored out to 1 3/4 inches. Here's the 2-inch ring for the outside, the far end of the spindle. I used a piece of 2-inch steel, cut it off at 0.325 inches wide, and then just threaded it with a carbide internal threading thing. Should be 1.5 inch, 24 now. I took a depth of cut of 51 thou. Here we're making the spindle for the 5C collet. I've got a piece of 1.5 inch steel that I've polished the outside of, and I just threaded it on the outside for the 1.5 inch 24 threads, and it worked out good. And I put this on by hand, the little ring, the 2-inch ring. I haven't even Loctited it in place yet, but I can't get it off because I faced off the end again, and it is solidly on there. So I'm about to start drilling and boring the center of the spindle out to 1.25 inches through the whole thing. Last night I bored the 5C spindle out. I drilled it out to 1 inch. Now I'm using my awesome Grizzly. This is my 3/4 inch boring bar. I use this thing for the cylinders on the locomotive. I've used it for a couple of other projects. It's really good. It's really effective. Gives a great finish. I'll show that when I'm done. Basically, using the DRO, taking off about 30 thou at a time. Just got to open this up to 1.25 inches inside. I drilled it out to 1 inch. Now I'm opening it up the final 1/4 inch, 250 thou. Alright, I finished boring with the large 3/4 inch boring bar. It's kind of hard to see the finish I got, but it's a good finish here. I may use my little honing stones just to make it perfect inside, but I wanted to show this, just like Matty does when he hits the spot on. Just luckily, look at that, within a shade, a thickness of the line of the 1.25 inch inside diameter. They're using the little telescoping gauges. So real happy with how that came out. The next step will be to put the 10-degree angle cut. I'll probably do that tomorrow, and then so I can fit the 5C collet. Let me show you what, in case you're having trouble visualizing what I'm doing here. Here's a 5C collet going inside, and the 10-degree angle cut gives the closure for closing mechanism, clamping mechanism, whatever you want to call it, for the collets that go in there. So that'll be next before I can take this off and flip it around. I'll probably take the ring off. Not quite sure about that yet, but I'm thinking I'll take that off before I remove this and flip it around. The rest of the design is actually the back part gets bored out slightly wider so that it fits the clamping nut that goes on to the back of the 5C collet and pulls the tension. So, and then there's a couple of other details in here, some keys that get put in. There's a key for the slot here in the collet, and there's a key in the back to key the index plate. I call it the hand wheel is what I call it, to key the hand wheel to the spindle. So I'll show more of that as we go on. Here I am cutting the taper for the 5C. It's a 10-degree angle, and it's not a surprising setup in any regard. I would just point out that I'm taking very light cuts and taking it very slowly, as you can see. About halfway through the angle, I've got a little 5C collet set right here that I just checked it with a minute ago, and I took a break and stopped it. Nothing really remarkable about this process. Just be careful with your setup, with both the angle and the cutting tool. Make sure you've got good clearance all around. I'm just using a little boring tool and set up so that I have minimal overhang and going really slowly. I'm using about 230 RPM on the lathe. You can go faster than that, but this seems to be making a nice cut. I'll bring you back when I get a little closer. Alright, so I finished boring out. I think I've finished as far as I'm going to go. Let me show you the fit. This is interesting. As you can see, the collet does not get quote-unquote sucked all the way in to the hole, but I'm hesitant to cut it any deeper because I'll be cutting into the rim of the tube that we've just machined here. I know that for a fact because as I was machining the last cut, which was only a 20 thou cut, it threw up a wire, so to speak. A piece of wire came loose that must have been a piece of the former rim of the inside of the tube of the spindle there. And I noticed on Dan's photographs that he sent me and he published on the Quorn.io group that he's the one that revised the drawings for the 5C. His 5C collets stick out just a little bit like that too. So I don't see anything wrong with that, and it might make it easier to pull one out if it got stuck or something. So I think I'm going to call that good right there. I do believe I'm going to have to unscrew, so I'm kind of glad I haven't Loctited this in just yet. I'm going to have to unscrew this to flip it around in the forejaw and work the other side. But I'll bring you back for that. Just kind of wanted to show you the fit. And it is a nice finish, and I have no doubt that that'll work adequately for clamping with the cutters. So there you have it. Just to follow up on my comment about the depth of cut and so forth, here I took the ring off. Again, I'm glad I didn't Loctite that on, because this part would have been impossible if I'd done that. Right here where my thumbnail is, that's where the little wire piece got thrown up. So I was cutting right into the very edge of the pipe, so to speak. Here, if you can see that, you can see where that broke off. Cutting right into the edge of the lip, maybe even removed about half of it. So I probably went a little bit too far actually. I'm very glad I didn't go any further. But as you saw when this thing was screwed on, it made a nice smooth receptacle, so to speak, for the 5C collet. So I'm taking this off so that I can reverse it and do the machining on the back side and put the little pins and so forth in here. But I'm glad I didn't take any further out. I'll mark this as to which part is the outside so I don't forget, so that I can Loctite it back together when I get done. Okay, back at it again. This is the spindle for the 5C collet holder, and this is the 1.5" portion. I just turned this part down to 1.460 inches and this part to 1.440 inches. So 40 thou off for here and an additional 20 thou off for here. And this part will get threaded now. So I'll be changing out the chucks, but I just finished polishing this up with a little emery cloth and I thought it looks good. After threading, the next thing to do will be to bore out the center part in the rear here, the back 1 3/4 roughly, for the nut that will retain the 5C collet. I'll bring you back to show you that. And now the back portion is threaded there. This is just to paint the picture here. On the spindle, this part of the spindle right here is where the casting will end. So the hand wheel will go up here, and then they call it the index plate. I like to call it the hand wheel. And then there's a retaining nut that will fit on the back part here that will hold it all together. And there's also, I'll have to put in here a couple of keyways, but I'll be working on that. I'll do that on the mill later after I've bored out the center rear portion. And I use my big boring bar, my 3/4 inch Grizzly boring bar again, to bore out the back section to 1.305. Let me get this, if I get a light in there, you can see it gives a super nice finish. So by 1.305 inside diameter by 1.74 inches long from the back. Alright, show a little trick. I've showed this before, but if you have to mark things 90 degrees apart, one way you can do it, build up a little set of blocks here for one of the jaws if you're using a forejaw. As you can see here, I've already scribed one line. This will be for the keyway that goes in and holds each collet secure. I'll be drilling and tapping a 1/4 28 hole in there, and I'm getting ready to scribe a line down here for the other keyway, other key, which will be the key that engages to the hand wheel. So a little tip there for the marking those things. They don't have to be 90 degrees apart. I just thought it'd look good. And just showing the setup for drilling and tapping the hole for the keyway that will hold the slots in the 5C collets. The keyway has to be 2¼ inches back and of course on center, and that it's tapped 1/4 inch 40. And happily, I just happen to have these British-made model engineer taps. You can see how fine that thread is. 1/4 40 is a very fine thread. I bought these taps, I believe, from it's a supplier in the UK. I think they came from, of course it says Apex on there. I either got them from Kronos or from a supplier called Tap Die Company Inc. I think these might be from Tap Die Company. but I've used them on a few different projects. I got these for making the valves for my live steam locomotive, so very happy to have those. And I'll be tapping and drilling this one. It says use number 5 drill for the pilot hole. So I'll first, now that I've got it all lined up, I'll machine a little flat there and then use a center drill and then the 5 drill and then tap. Here we are finishing up milling a 3/32 inch slot for a conventional half moon key. Taking it really easy, going only like 5 thou at a time depth of cut. I'm only going about half the wall thickness. The wall thickness here is 77 thou, so I'm actually only going like 38 thou depth of cut. You can't really see that. There you go. On my DRO. So I'll take this off in a minute, clean it up, and we'll see how well the key fits. There we go. Little half moon key. I ground the edges off of it a little bit. I can show you. There we go, so it won't be quite as long. And like I said, this is a 3/32 inch thick one. And I got this idea from Dan Watson. Dan is the one that redrew or added to the Quorn 5C information in the quorngroups.io. And he suggested using this, so I think I'm going to do the same thing. I'll custom fit this a little bit and then Loctite that into place. I think that's going to be a good solution. I decided to make my little screw, the indexing screw for the 5C collets, out of brass. So I've turned a little 1/8 inch by 100 thou deep tip, and I just threaded a 1/4 inch 40, a little section of the brass rod, and I'm about ready to cut it off, and then we'll test fit and see how it goes. And here's the finished screw. I just used the Dremel tool to cut a little screwdriver slot in there. You can see the little 1/8 inch pin, and then see if we can get that to focus. The 1/4 inch by 40 threads. So I'll try threading this into the collet holder now.